Hello, welcome to Deck Digest for February 18th. Starting things off, Anna's archive recently published their llms.txt file, which is like agents.txt file, various names here. So this is protocol for AI agents, and the goal is to give models programmatic access to the massive data set here. This is, to be honest, this is a pirated data set. They scraped everything off the internet, including music. We talked about the lawsuits against them, and now they are designing prompts here so that the client agents can ingest data more efficiently from this pirated data set, and to save on token limits, etc. So developers are, of course, already noticing a lot of big corporate crawlers are completely ignoring these files, files like this for agents and LLMs. And instead, they hammer servers. There's a lot of scraping going on right now on the internet. This particular website is famous for showing up in various training data sets, unfortunately, although this data is completely illegal. But this is top news today. Moving on, so we talked about Asahi Linux. They just dropped the new version, progress report for 6.19, and this is a huge milestone. So if you saw the hardware support on their homepage, noticeably missing was DisplayPort over USB-C, which is how 99% of people probably use their Macs. So it is living in the experimental fairy dust branch and restricts output to one specific port on your Mac, but it means that native external monitor support is finally becoming a reality after honestly years of waiting for this. And getting here wasn't easy. So if you read this article, they have custom GPU driver with over 20,000 lines of code. But the good news is their out of tree patch burden has actually shrunk by 12,000 lines as more of their hard work gets officially emerged upstream into Linux. So that's cool. Definitely interesting to see here. This is almost the last thing that you need to actually effectively run Linux on M processors. Very cool. If you have ever thought with restrictive cloud environments and hard NATs, Tailscale's new peer relays are now in GA. So instead of relying solely on Tailscale default derp servers, they can now deploy your own. You can now deploy your own high-throughput relay nodes directly on your infrastructure. And what makes this powerful is support for static endpoints, meaning you can park these relays behind cloud load balancers to establish full mesh routing without exposing everything. Plus, they have hooked up to Prometheus and Grafana, so you can track every forwarded packet and byte across your tailnet. Very cool. The Ladybird browser team has officially pulled the plug on their multi-year effort to adopt Swift. In their issue tracker, developers noted that Swift ended up feeling far more complex to work with than even mature languages like C#. The fatal technical hurdle was memory management. They couldn't seamlessly bridge Swift's natural memory handling with Ladybird's custom C++ garbage collector. And generating the necessary memory graph traversal functions like visit edges required deep expertise in Swift macros that the team just didn't have. So it made the interoperability overhead too high to justify. The reaction here is mixed. So some people, of course, complain about Swift complexity and the C++ interop, but Swift people, they talk about tooling limitations that actually are outside of Apple ecosystem. So we'll see. I'm sure somebody will fork this and say it's easy, but we'll see. Researchers at university here. So 2 yen, I hope I pronounce this correct, and terabyte. They have just set a new world record for data density by creating QR codes smaller than a single bacterium. And here it is, right? So they used focused ion beam, and they engraved highly stable ceramic thin film with pixels measuring microscopic 49 nanometers. So this is roughly 1/10 of a wavelength of visible light. So this is these particles here. Let's see, each pixel is 49 nanometers. So so you can you literally need electron microscope to read this, of course, and the implications for cold storage are pretty wild. This density, single paper sheet with this material could hold over 2 terabytes of data, and it remains intact, of course, for centuries with zero cooling or power required. And of course, it's going to be some degradation here at this scale, but you can add redundancy. That's pretty cool. I wonder how fast it actually goes. Next in use is this gist. So if you spend a lot of time in the terminal, you probably notice standard 256 color palette, and it often clashes terribly with custom 16 color based themes. So this developer here, he published a technical proposal arguing that terminal emulators should auto-generate the extended color cube and grayscale ramp dynamically. So the default terminal palette actually interpolates shades incorrectly, making background colors too light and rendering hues like blue and green with wildly inconsistent brightnesses. By using trilinear interpolation with the lab color space, emulators could generate mathematically consistent, reliable colors that perfectly match your base theme. And there's some examples here. Interesting to see it in the gist, but yeah, there's a lot of examples of this working somewhat incorrectly. And the comments are highly supportive. Developers agree that the standard terminal interpolation is mathematically flawed, and they want emulators to adopt this dynamic generation. That would be cool, especially seeing that we have so many colorful CLIs now with Claude and Copilot and the rest. But we'll see where the pendulum will swing this year. Maybe we'll go back to UIs. There's a massive breakthrough in biotech out of Stanford that could fundamentally change how we treat joint damage. So researchers have developed an injectable small molecule drug that blocks specific protein called 15-PGH. This is incredible here, and it's a mechanism that is incredible. It doesn't rely on transplanting stem cells. Instead, blocking this protein directly reprograms your existing aged cartilage cells, what are they called? Chondrocytes, okay, and then forces them into youthful state where they start regenerating functional tissue. In lab tests, just 2 localized injections a week measurably thickened knee cartilage and halted progression of osteoarthritis. Very cool. Hopefully before I get too old. This is actually in humans. Let's Encrypt is rolling out a brand new Acme challenge type called DNS Persist 01. And it's going to drastically simplify automated certificate renewals. Historically, DNS 01 validation forced you to write a new TXT record every single time a cert renewed, which meant scattering sensitive DNS API keys across all of your automation pipelines, because you need to automate this, of course. Don't want to cause another DNS issue. The new model changes the game by using a single permanent DNS record that cryptographically binds to your specific Acme account key. You're trading real-time proof of freshness for a massive security win. Your infrastructure can keep requesting certs indefinitely without ever needing write access to your DNS zones again. That's pretty cool. And wrapping up today, another network-related thing. Google's public certificate authority experienced a major incident that forced them to completely halt all new certificate issuance. So while seeing a Google service intentionally pull its own plug is rare, it's exactly how WebPKI ecosystem is designed to work. If certificate authority detects a bug that could lead to issuing non-compliant certificates, ones that violate strict baseline requirements, their only safe move is to stop the process immediately. So failing to do so risks having entire CA distrusted by all of the consumers like major browsers, meaning that they have to prioritize strict cryptographic compliance over the uptime. Oh, very cool. It shut itself down. I'll see you next time.